Alright, this is notes on 2.5. Notes on 3D figures. Objectives: you'll be able to find the volume of a cone, find the volume of a rectangular prism, find the volume of a pyramid, and find the volume of overlapping figures. So first things first, how to find the volume of a cone? Well, that's equal to 1/3 times pi times radius squared times height. So we're going to be finding the volume of these guys. So, for example, problem number 1. We got a height of the cone which is 8 kilometers. And then the radius of this cone, the radius of the bottom of the cone is 4 kilometers. So what we do, we plug those numbers into our formula. So volume is 1/3 times pi times, well, radius times radius, 4 times 4, times the height, which is 8. So that's what the formula says. Then we simplify. 4 times 4 is 16. 16 times 8 is 128. So volume of 1/3 times pi times 128, that'll get you 42.6 bar notation times pi. Then we multiply that out, and we get a volume of 134.0412866 ... an irrational number. Look at number 2. Our radius is 8 yards, and our height of a cone is 16 yards. So we plug things into our formula, and we get a volume of 1/3 times pi times 8 times 8 times 16. Because remember, it's radius squared, so the radius appears twice, 8 times 8. 8 times 8 is 64. 64 times 16 is 1024. 1/3 of 1024 is 341.3 bar notation. That should be a bar above. Times pi. And that number times pi gets you 1072.330292 ... And that's the volume of the cone. Last one. This one's a little bit trickier. Our diameter is 24. So to find the radius, we have to do half the diameter. So half the diameter is 12. So the radius is 12. Now that we know that, we plug it in. 1/3 times pi times 12 times 12 times 24, because the height is 24. 12 times 12 is 144. 144 times 24 gets you 3,456. 1/3 times 3,456 gets you 1,152 times pi. Multiply that out, and we get 3,619.114737 ... And that'll be the volume of this cone. Now we could do a worksheet to get a little more practice, or one of the Google forms that you see attached for volume of a cone. Next up, volume of a cylinder is pi times radius squared times height. So we're going to plug that in. So here's 3 problems or 4 problems on how to do that. So we have a cylinder. The diameter of the cylinder is 14 feet, so once again, we have to know radius is 7 feet, because it's always half the diameter. So that's going to be 7. And the height is 6 feet. So we plug it into the formula. So that's our formula. We plug it in. Pi times radius squared, so radius times radius. So my radius is 7, so 7 times 7. Then times the height, 6 feet. 7 times 7 is 49. 49 times 6 is 294. We have 294 times pi, which is going to get you the irrational number of 923.6282402 ... And that's the volume. When you round it, 923.63 feet cubed. Number 2. So we'll do another one. Once again, they give you a diameter of 16 inches, so we have to know that the radius is half of that, so it's 8. We plug it into our formula. There's our formula. And here's my work. Volume is equal to pi times radius squared, so 8 times 8. And then times the height, which is that last times 8. 8 times 8 is 64. 64 times 8 is 512. So I have 12 times pi is 1608.49. Dot dot dot. So it turns out it's B for number 2. Number 3. It's a popular trick that people like to do. They're giving you the diameter, so the radius, half of 22 is 11. There's our formula. So volume is equal to pi times radius squared times height. So radius is 11. So 11 times 11 times 16. 11 times 11 is 121. 121 times 16 is 1936. That number times pi gets you 6082.123377 dot dot dot. That irrational number. So volume of a rectangular pyramid, volume is equal to 1/3 times base times height. So pyramids are a little bit tougher because of the word base. What exactly is the base? Well, the base is the bottom piece of your pyramid here. So this base, it's referring to what is the volume or the area of that bottom square or rectangle. So it's this guy right here. I highlighted here in blue. So that base is 2 times 2, which is 4. So the base is 4 meters squared. So when we do our work, I wrote out the 2 times 2. So volume is equal to 1/3 times 2 times 2 times the height of 2. So we already know the base is 4, that's why I got that 4 there. So volume is 1/3 times 4 times 2. 4 times 2 is 8. 1/3 times 8 gets you 2.6. Bar notation. Oops. And that's the volume of this triangular pyramid. Number 2. Once again, base is the tricky word here. So the base in this one is the rectangular base, which is 3 times 4. Which, as you guys know, is 12, and that's going to be that first part. So I do volume is equal to 1/3 of 3 times 4. So that base is that 3 times 4, which gets us to 12. 1/3 times 12 times 5, well, that's the same thing as 1/3 times 60. 1/3 times 60 is 20. So it's 20 inches cubed. Looking at number 3. Same process. We're finding the volume. We know the formula. So the base is the 11 times the 18 gets us the base. So 11 times 18 gets us the base, which gets you 198. The height is 14. So 198 times 14 gets you 2,772. And times the 1/3, which gets us the volume of 924 miles cubed. Alright, now, in this one, a rectangular base is no longer a rectangular base, it's now, we have a triangular base. So it's a little bit different. So it's referring to this triangle down here. Now, what do we know about triangles? Well, you know that's half base times height. So our base times height for these two numbers, these two lengths, because the 5 is the diagonal. 4 times 3 is 12. So our base is going to be 12. How I wrote it out, I did volume is equal to 1/3 times, well, my base is 3 times 4 divided by 2. So I do 3 times 4 divided by 2. That gets you 12. 12 divided by 2 is 6. So our base is actually 6. Volume is equal to 1/3. Well, I just wrote out my work. So I got the 6. 1/3 times 6 times 4. Well, 6 times 4 is 24. 24 times 1/3 is 8. So we have a volume of 8 centimeters cubed. Number 2, we have this. Volume of the rectangular pyramid. Plug it in, the base 6 times 8 divided by 2, which gets you 48 divided by 2, which is 24. So 1/3 times 24 times 10. 24 times 10 is 240. 240 times a third gets you 80. So the volume of that guy is 80 inches cubed. Number 3. Once again, we have the triangular base. 3 and 4, because we forget about the hypotenuse. We don't have to worry about that. So 3 times 4 is 12. 12 divided by 2 gets us 6. So that area of the base on the bottom is 6. So there's a work. So we got the area of the base is 6. 6 times 7 gets you 32. 32 times a third gets you 10.6 bar notation. Okay. Next up is volume of a sphere, or sphere. So your volume is equal to 4/3 times pi times radius cubed. So volume is equal to 4/3 times pi times radius cubed. You plug in the radius, which is 1, because remember, when they're given a diameter, we have to find the radius, which is just half the diameter, so it's 1. So you have 1 cubed. So 1 cubed is 1 times 1 times 1, which is really just 1. So right here is just times 1. So 4/3 times 1 is 4/3, so our volume is 4/3 pi for number 1. And when we do 4/3 times pi in a calculator, we're going to get, I believe, 1035, but let's put in a calculator. 4 divided by 3 times pi gets you 4.188, which is the same thing as B, 4.19 kilometers squared. So when you put it in a calculator, you're going to get that. Number 2. So we got the radius of 13. So we plug that in. 4/3 times pi times 13 to the third power. 13 times 13 times 13 gets you 2,197, which is what we have here. 4/3 times 2,197 gets you 2,929.3 bar notation. And times pi, and when you multiply that times pi, you're going to get 9,202.77208. That's the irrational number. And we see that it is B. Number 3. If the diameter is 6, that means the radius is 3. We plug that into our formula. 3 to the third is 27. 27 times 4/3 gets you 36. 36 pi is 113.097. ... Alright, so now some volumes of overlapping figures. That's where it looks a little bit tougher, and you could handle it. As all it is really just 2 volume problems. So what this says is Anders is using casts to make plastic figures. He has a cylinder cast that has the diameter of 6 inches and is 30 inches tall, as we see here. Anders uses a cone-shaped container over here with a diameter of 3 inches and a height of 12 inches to fill his cast. How many cone-shaped containers, so how many of these cones full of plaster will he need to completely fill the cylinder cast? So how many little cones go into the big cylinder? Well, we first find the area of the cylinder. I'm going to use that formula, and there's my work. Find out it's going to be 848.23. Then I find the area of the cone, or the volume of the cone, We get that to be 28.2743. Then what we do is, since we do big divided by small, so 848. So how many of these cylinders, how many of these cones go into the cylinder? So 848 divided by 28.27. That's going to get 30. So you could fit 30 of these cones into this cylinder. And that's our answer. This one, same story. We have the volume of a cylinder. So our volume of a cylinder and the volume of a sphere. We want to know how many cylinder-shaped containers full of plaster we'll need to completely fill the spherical cast. Gotta fix that one. We want to know how many of these cylinders go into the sphere. So this is the volume of the sphere. I'm sorry, the volume of the cylinder, 134.303. The volume of the sphere, which is just like we practiced before. So we got 904. So how many of these cylinders are going into the sphere? Well, you divide it out, like you see there. And you do 904 divided by 134, we're gonna get 6.7 dot dot dot. So any irrational number. And that's how many cylinders could go in that sphere to fill it up. Alright, here's your classwork and your homework. If you have any questions, feel free to email me or come next up. I'll be happy to help you out. Alright, have yourself a good night.